Is this confirmation of the presence of one more universe? For north of 2 years at this point, the James Webb Telescope has been homing in on the most profound mysteries of the universe. What's more, it has already identified an entire scope of designs that, according to our understanding, shouldn't exist at all here and where our current models have reached their limits. A hypothesis, at last, becomes possibly the most important factor, and the English physicist and Nobel Prize champ Roger Penrose is its most well-known advocate. No, the Big Bang was not the start of everything, but simply the dangerous transition between two grandiose parts. As a matter of fact, Penrose is convinced that the universe has forever been subjected to a cyclical pattern of obliteration and resurrection. And incredibly, the latest discoveries now even suggest that he is right. But what about the mysterious selling points, which, according to Penrose, encapsulate the remnants of a past universe? Limitlessness is limited. Well, basically for us. Although many specialists suspect that the universe is endless from our natural perspective, we are only able to see an imperceptibly small part of the entire. Our round field of vision is properly alluded to as the observable universe, and it includes the region from which information could have reached the Earth since the Big Bang. Given that the celestial birth took place 13.8 billion years ago, one may imagine that the distance to our normal view, the supposed event horizon, is also 13.8 billion light years. Yet, that is not true. After all, the universe that is space has been constantly expanding since the dawn of history, which means that distances previously covered have been extended reflectively, and the distance to the perception horizon is eventually estimated at 46.3 billion light years. What's exciting here is the fact that each point in the universe has its own recognizable universe. In other words, if there is a civilization billions of light years away out there, it can see a piece of space that will forever remain the great unknown to us. Because of these infinite signals, specialists can conjecture about what lies dormant outside our field of vision. While many specialists believe that the designs there correspond to those in the local universe, others estimate that the invisible depths of space are much stranger than we can even imagine. Anyway, the black hole that the James Webb Telescope added to the star diagrams a few weeks ago was also much stranger than we could have ever imagined. Dedicated with the scientific name 568, the gravity beast had already existed for 1.5 billion years after the Big Bang. But despite this, it evidently consumed matter multiple times faster than is theoretically possible. However, we should be clear. This puzzling Webb discovery in no way denotes a cosmic special case, but rather corresponds to the new baffling design we now know of a whole series of black holes that just appear too large for their initial development. These include the quasar, a functioning cosmic core called J120+0641, which dates from the cosmic sunset time, but currently weighs over 1 billion solar masses. To the scientists' alarm, however, a closer assessment with Webb's mid-infrared instrument, MIRI, failed to uncover any exceptional feeding component. So, incidentally, we simply don't know how a very large black hole could have been fully grown when the universe was only 5% of its current age. Since our current models can no longer explain the vast premature children of the observable universe, new approaches must be considered. And the fact that these occasionally have the potential to alter how we might understand the universe is demonstrated by Sophie Kidman's comments. When asked if the surprisingly large black holes could have formed from structures that existed even before the Big Bang, the astrophysicist from the University of Cambridge responded, "The astonishing thing about this question is that nothing is precluded. Some people say that the mass of black holes we have now observed in the early universe probably formed by an immediate collapse. There are a few publications that suggest the observations demonstrate this. If black holes develop effectively, they have barely enough time to grow from a very light seed." However, although Kidman emphasizes that this model is just one of many explanations, it presents a notable reason, in particular, that there really was something before the Big Bang and consequently, before our universe. The cyclic model, the end as a beginning, The fact that current cosmology has reached its limits in a vast number of regards is also shown by the Webb discovery, which triggered the galactic emergency. After all, as soon as February 2023, the word had already gotten out that there were 6 incredible galaxies out there that were as gigantic as the Milky Way may be today, a good 10 billion years ago. However, since this startling finding was in distinct contradiction to our theories about the density of matter in the early universe and about galaxy development, the mystifying objects quickly earned the epithet universe breakers. And, of course, some galaxies in the young universe were much more efficient at converting gas into stars than others. Essentially, that was the conclusion reached by a research team from the University of Geneva who studied 3 cosmic heavyweights, also known as the red beasts, due to their appearance in the Webb pictures. According to our speculations, galaxies structure somewhat slowly inside coronas of dark matter. These capture particles and atoms and bind structures around them with their gravity, from which galaxies eventually grow. But while, generally speaking, only around 20% or less of the captured gas is converted into stars, the corresponding proportion in the case of the red beast is an incredible 50%. Yet again, the fact that the design survived this around 1 billion years after the Big Bang remains a mysterious problem in astronomy. For the time being, all we know for sure is that something must have happened in the earliest Big Bang sections that paved the way for the shocking development of galaxies. But what if that's not true? What if the foundation for the development of the universe was not laid with the Big Bang, but before that? Well, then we would have arrived at the heart of a surprising theory that Roger Penrose has been advancing for quite some time, respected with the Nobel Prize in Physics in 2020 for his research on black holes. The English mathematician and physicist is convinced that the universe is cyclical. Thus, Penrose doesn't see the Big Bang as the frequently cited start of literally everything, but just as a transition between 2 ages of 2 astronomical life cycles. True to the saying, each end is followed by a fresh start. The universe would continue to expand until all matter has deteriorated and become light, as indicated by Penrose. This limit, a climate in which nothing has a period or space reference to each other, will inevitably lead to another large pack, over and over again, as a component of each infinite finale. The dark openings will likewise vanish totally and, subsequently, deify themselves in the following universe as an exceptional remainder that vouches for the presence of the past universe. However, that is not all. Penrose professes to have found exactly these obvious traces in the vast microwave background. Exhaustively, this refers to various round spots that should be visible in both the board and the WMAP satellite data. Just to clarify, the cosmic microwave background radiation, CMB for short, is an artifact from the beginning of the universe, created approximately 380,000 years after the Big Bang during the recombination epoch. It now permeates the entire universe. To understand why the discovery of supposed selling points could be so significant, we must first understand that the cyclic model places cosmological expansion before the Big Bang. This generally refers to a period of incredibly rapid development of the universe, during which the universe experienced an unmatched growth spurt right after its creation. But if we now place this inflationary growth before the birth of the universe, we are dealing with the consequence of the dramatically extending fate of a previous age. Fundamentally, the change from age to age is sound from both a numerical and an actual perspective, although very large black holes present an exception. These black holes would have nearly totally consumed the cosmic system groups in their current environment toward the end of a large epoch before they dissipated completely into selling radiation. They would carry the entire transmitted energy with them into the ensuing universe as a single selling point. The photons generated in this cycle would thus be found in a growing region, which, however, only becomes apparent when it finally shows up in the microwave background radiation of the new universe. On paper, such a selling point would appear as a circle the diameter of the full moon. And, indeed, the data reference have uncovered precisely that in the microwave background, To be more exact, the ominous spots correspond to products of the typical CMB temperature variations. In fact, specialists had assumed that such features would have been completely wiped out by cosmological expansion. Considering this exciting discovery and all the cosmological anomalies revealed by the James Webb Telescope, is it possible that our reality doesn't relate to the one universe by any means, but only to the current cycle? Well, that is exactly the focal point of the galactic discussion, which is far from over. But regardless of whether the universe truly is subject to an eternal cycle of annihilation and resurrection, some fundamental questions remain unanswered. What, then, marked the starting point of the cycle? Is there such a concept as a starting point in infinity at all? And will humankind one day succeed in fully understanding the world in which it lives? Well, who knows? But certainly you see that you should now click approval and the subscribe button if you never want to miss another new video from us again. Go ahead and become a part of our community to stay up to date. We'll see you soon.